under rotation of a rigid body. We are told that a wheel of mass 10 what kg. A wheel of mass 10 what? So from there we're giving our mass. Our mass is 10 kg. Do you need to convert to kilogram? No, because it's already in what? Kilogram. Supposing it was a gram, what do? You divide by 1000 to convert to what? Kilogram. And we're told that and radius of gyration, that's your arrow, was given to be what? 60 centimeter. Okay, what do? Convert to what? How do you convert to meter? Divide by, okay, setting at 60 over what? 100 equals to 0.6 meter. So the next we are told that is rotating at 400 rpm. What's rpm? That's omega, right? That rev per what? Minute. So we are giving our W to be 400 rpm. What do? Convert to what? Rad per seconds. How do you convert? Multiply by what? 2 pi, then divide by. That's good. So we have 400 times 2 times 3.142 divided by what? 60. So our W will be equals to, we are multiply 400 times 2 times 3.142. 400 times 2 times 3.142. 2513.6 divided by 60. Divided by 60. 41893 rad per what? Rad per what? All right. And we are told to find each what? Moment of what? Inertia. Moment of what? Inertia. So moment of inertia is setting as I. So we are looking for I. There, and each rotational kinetic energy. Rotational kinetic energy is written as KER. Are you following? All right. Now, to look for inertia, so our inertia is I equals to mr square. Are you following? Inertia is equals to what? Equals to mr square. So our inertia will be equals to what's mass? 10. Mass was given to be 10 times what's radius? 0. What? Then square. Then our I will be equals to 10 times 0.6 square. 0.36. So what will be our I? 10 times 0.36. 3.6. The SI unit is what? Kilogram meter square. Kilogram meter what? Square. Mass is in what? Kilogram. Radius is in what? Meter. And the square. All right. That's number 1. So number 2, we are asked to look for what? Rotational kinetic energy. I gave you just one formula for rotational kinetic energy. All right. For our KER, KER is equals to 1 over 2 IW square. Is it not? KER is equals to what? 1 over 2 IW square. So from there, our KER will be equals to 1 over 2 times what's moment of inertia? What's moment of inertia? 3.6. Then times what's omega? What's omega? All right, we have 41.893. Then there is what? Square. All right, KER will be equal to half is setting as 0.5. Half is setting as what? 0.5. Then times 3.6 times square this for me. 41.893 square. 1755.02. 02 what? 3449. We are multiply everything. Three one five 9.04 what? 2208. So approximately 3159.4. Okay. 0.04. Okay. That's 0422, right? Let's say 04. Anything energy is in what? Joule. Anything energy is in what? Joule. Work done is in joule. Potential energy is in joule. Kinetic energy is also in what? Joule. Be it rotational or linear, as long as an energy. Is that clear? So the SI unit is in what? Joule. All right, copy that. KER. This one. This conversion. This one is the KER now. Okay. It's half initial W square. So this is the half. What was initial? What was our initial? We got 3.6. Then what was W? Is this? Are you following? All right. So if you divide this, 1 divided by 3 is sitting as what? 0.5. Then we have 3.6. Then times 41.893 square is going to, so when you multiply everything, then it's going to, okay. So let's move to the second question. We are told that a 600-gram uniform sphere, a 600-gram uniform sphere of 9 centimeter radius spins at what? 50 rev per seconds on an axis through its what? Center. We are asked to find its rotational kinetic energy, angular momentum, radius of what? Gyration. All right. So from this question, we are told that 600 gram. We were given our gram, right? Which is our mass, is it not? So what was our mass? 600. What was our mass? 600 gram. What do you do? Convert to what? Kilogram. By divided by 1000. So it's sitting at 600 divided by 1000. That is 0.6. 0.6 what? Kilogram. They say of 9 centimeter radius. You were giving your radius, right? So what's the radius? 9 centimeter. Is it in meter? What do you do? Convert to by divided by what? That's 9 over what? 100. That is 0.09 what? Meter. They say at 50 rev per second. Rev per second is sitting as what? Omega. So here we're getting our W to be what? 50 rev per what? Seconds. What do you do? Convert to what? Rad per second. By multiplying by what? Do you need to divide by 60? No. Why? Because it's in seconds, right? Supposing it's per minute, what do you do? Divide by 60. So this time around, it's sitting as 50 times 2 pi. Is it not? That is 50 times 2 times 3.142. So what do we have? 314.2 rad per watt. All right. Now we are asked to find number one, the rotational kinetic energy. Rotational, that is Ke what? Number two, we are asked to look for what? Angular momentum. So angular momentum is written as what? L. Then number three, we are asked to look for what? Radius of what? Gyration. I say when calculating radius of gyration, you can represent it with what? K. Sometimes you might also represent it with what? Arrow. Because your radius of gyration, it was gotten from I equals to m arrow square. Are you getting me? If you are changing your radius to K, it's sitting as I equals to what? Mk square, isn't it? So if you make K square the solid of the formula, what do you divide both sides by what? M. So at the end, if you divide by M, then this will cancel out, is it not? You have it as K square equals to I over M. To get your K, you square root both sides, right? It becomes square root of what? I over M. You can see that your K is sitting as your arrow, is it not? All right. So this time around, so let's look for KER. And KER is equals to 1 over 2 IW square, isn't it? All right. Now this time around, do we have our I? No. Do we have moment of inertia? No. What do? You have to look for moment of what? Inertia. Once I got your moment of inertia, I cannot substitute it into the formula to get your KER. Is that clear? All right. And to get our moment of inertia, I gave you several formula for moment of inertia. So whenever you are giving a question, be very careful. Okay, unlike this question, we were told that a uniform sphere. This a uniform sphere through its what? Center. This a uniform sphere through its what? Center. Again, for uniform sphere through its center, right? Yes. We also have moment of inertia that is for uniform sphere through one end. If it's through its center, it's 1 over 2, sorry, 2 over 5, then m r square. But if it's through one end, it becomes what? 1 over 2 m r square. So which are we to use? 2 over 5, is it not? All right. So this time around, our I will be equals to 2 over 5 m r square. Are you following? So from there, our I will be equals to, we have 2 over 5, then times, what's m? What's m? 0.16. Then what's radius? What's radius? 0.09. And there is square there, right? What do? You square it. So from there, we have it as I, then equals to 2 divided by 5. 2 divided by 5. 0.4. Then times 0.6. Then times 0.09 square. 0.09 square. 8.1 times 10 minus what? 3. All right. So our I will be equals to multiply through 0.4 times 0.6 times 8.1 times 10 power minus 3 times 10 raised power what? Minus 3. 1.944 times 10 raised power what? Minus 3. What the SI unit for moment of inertia? Kilogram meter square. Kilogram meter what? Square. Kilogram meter what? Square. All right. Now that we've gotten this now, we can now substitute. Yes? That's the formula we use now for moment of inertia through one end. If it's a uniform sphere through its center, we make use of 2 over 5. If it's a uniform sphere through one end, it becomes 1 over what? 2. If there's no a uniform sphere through its center or through one end, make use of what? MR square. Are you following? All right. So this time around, from where? This one. Yes. This is how we arrived there now. Our 2 divided by 5 is what? 0.4. Then we have our 0.6. 0.09 square. It will give you what? It will give you this. Is that not what your calculator give to you? 0.0081. Yes, now this one is in ordinary form. Are you getting me? If you want to express it in standard form, it's written as 8.1 times 10 raised power minus 3. Minus 3, you are telling us that it has how many zeros? 3 zeros. So if you have 0.000012, how do you express it in standard form? 1.2 times 10 raised power. How many zeros do you have? They become minus 5. Minus 5 means you have 5 zeros. Are you following? If you have 1.3 times 10 raised power minus 100, how many zeros do you have? That is 100 was 0.00000012. Are you following? So that's it. So from here, we've succeeded in getting our what? We succeeded in getting our moment of inertia, right? All right. Now to get our KER now, that is 1 over 2 IW square. So it becomes 1/2 times what's I? 1.944 times 10⁻³ then times what's omega? 314.2. So we are 314.2 then square. So half is sitting at 0.5 times 1.944 times 10⁻³ So 314.2 square. 98721.64. So if you multiply through, what do we have? 95 point what? 95 what? 7. That's Joe. Alright. That's for number 1. So number 2. We are asked to look for what? Angular momentum. I gave formula for angular momentum, right? So our L is equal to IW. Are you following? So our L will be equal to what I? 1.944 times 10⁻³ what? 3. Then times what's W? 314.2. We have multiplied through. What do we have? Multiply. 0.61 0 what? All right. So the SI unit is kilogram meter square per seconds. Kilogram meter square per what? All right. The last one, we are asked to look for what? Radius of what? Gyration. Our radius of gyration K is equal to square root of I over what? M. Are you following? So from there, this is taking as square root of what's I? 1.944 times 10⁻³ divided by what's mass? What's mass? 0.6. So our K will be equals to, now divide this. Divide this. 1.944 times 10⁻³ divided by 0.6. 3.24 minus 3. Is that what you got? What do you have? (1.944) exponential minus 3 divided by 0.6. 3.24 times 10⁻³ So what's square root of that? 0.0569. So our final answer there give us what? 0.0569 meter. So that's our answer. Now please pay attention. Pay attention. Let me explain something here. If you observe, this thing here is the standard form, right? Is the standard form, is it not? If you punch your square root like this and you write this value like this without you make use of exponential, are you getting me? Your calculator will only square root this 3.24. Are you following? And what's square root of 3.24? What's square root of 3.24? 1.8. It will not give 1.8 times 10⁻³ What I'm trying to say is that if you punch your square root 3.24 and you write 10 times 10 raised to power minus 3, can still give you 1.8 times 10 power minus what? 3. Are you following? Your calculator will only square root the 3.24 and it will neglect the what? Times 10 raised to power minus what? 3. So the best way to do that, hello, is that first of all, you punch your square root from your calculator. Then you open up brackets. They write 3.24 times 10 raised to power what? minus 3, then cover the square root, then press equal to. Now what you are telling your calculator now is that the calculator should square root everything that is inside the word bracket. Are you paying attention? The calculator should square root everything that is inside the word bracket. If you don't want to use normal times 10, you can just go ahead and punch your square root of 3.24, then make use of exponential minus 3, and it will still give you the what? The direct answer. Are you following? So be very, very careful. If you all punch it without bracketing it, putting the bracket, your calculator will only square root this and it will neglect this one, and then add 1.8 times 10. You still have times 10 per what? Minus 3. Are you following? Please be very, very what? Careful. All right, so that's our final answer. Any question? All right. Yes. This question normally comes out in exam. Oh. You don't see how many times I be. Master and you go still come out again. You go still come out again. The man don't get time. Question. We were told that a constant force of 60 Newton is applied tangentially to the rim of a wheel with 40 centimeter radius. The wheel has a moment of inertia of 50 kilogram meter square. Now we are asked to find number one, the angular acceleration. Number two, the angular speed after 6 seconds from rest. Hello? 6 seconds from where? Rest. I think whenever you hear the word rest, rest is what? Zero. Rest is what? Zero. That's good. All right. Then we are told that the number of revolutions made in that was 6 seconds. And the last one, they say show that the work done on the wheel in the 6 seconds is equal to the rotational kinetic energy of the wheel after what? 6 seconds. All right. Now the word show means to prove. Hello? The word show means what? To prove. It simply means that the answer that you are going to have in your work done, hello, must be equal to the answer that you are going to have in your what? Rotational kinetic what? Energy. If what you have in your work done is different from what you have in your kinetic energy, it's simply that your working is what? Is wrong. Are you following? So the two answers must be what? Equivalent, must be equal. All right. Now let's bring out the parameters. We are told that a force of what? 60 Newton. So we are giving our force, right? That's 60 Newton. Then it's applied tangentially to the rim of a wheel 40 centimeter radius. So we are giving our radius to be what? That 40 over what? 100. 0.4 meter. And we are told that the wheel has a moment of inertia. That's our I, right? So what's our I? 50 kilogram meter square. Now we are asked to find A, the angular what? Acceleration. That's what? Alpha. That's good. Then the next one is what? Angular speed, which is what? Omega. All right, that's W. Now they say after 6 seconds from where? Rest. From rest. So yeah, we're giving our what? Time. That means what we have to look for is W2, right? Yes. So we're giving our W1 to be what? 0 rad per what? Second. And the time there was going to be 6 what? Seconds. Are you following? All right. Now this time around, they say the number of what? Revolution made in that 6 seconds. Number of revolution is taken as what? Theta. That's good, theta. So number 4, we are now asked to show that the work done, that is our work done, must be equal to what? KER. Are you following? Yes. All right. For the first one, we are looking for alpha, and we are giving us this, and this. And I gave you a formula that relates moment of inertia and alpha, right? I gave you torque. Remember, I gave you torque equals to what? Initial alpha. Is it not? Hello, I gave you torque equals to initial alpha now, right? So we can get our alpha from here. Our alpha will be equal to torque over what? Inertia. So from here, our alpha will be equal to torque over what? Inertia. Our alpha will be equal to what? Torque over what? Inertia. But the problem here is we have our moment of inertia, but we don't have our what? Torque. Are you following? We have moment of inertia, but we don't have what? Torque. What do you need to do? You have to look for your torque first, right? And to look for torque, you have force and you have radius, is it not? I told you that your torque is equal to force times radius. Are you following? Torque is equal to what? Force times radius. From there, torque will now be equal to what's force? What's force? 60. And what's radius? 0.4. So our torque will be equal to 60 times 0.4. That's 24. 24 what? Force is in what? Newton. Radius is in what? Meter. That's where they got the SI unit for torque. Torque is Newton meter. So now that you've gotten your torque, hope this part is clear. Yeah. We can now substitute this torque into this formula to get our what? Alpha. Because we have our I, is it not? Which is moment of inertia. Now we now have our what? Torque. So from here, alpha is equal to torque over what? Inertia. So what's torque? 24. That's 24 over what's? 50. Over 50. So what do we have? Divide. 0. What? 48 rad per second square. All this part is clear. Yes. Now that you got your alpha, now the next thing you will have to look for W2. Now you have W1, you have time, and we have alpha. We can get our W2 now, right? Don't forget number 1B. We have alpha equals to what? W2 minus W1 over T. Is it not? What are we looking for? W2. So what's alpha? 0.48. What's alpha? 0.48. So we have 0.48 equals to, we are looking for what? W2. Minus what's W1? 0. And what's time? 6 seconds. So we have 0.48 equals to W2 minus 0. That's W what? 2. All over what? 6. So what do we do? They cross multiply. So our W2 will be equal to 0.48 times 6. So W2 will be equal to 0.48 times 6. 2.88 rad per seconds. Alright, the C of it. We are asked to look for what? Theta. Now we have W2, we have W1, and we have time. You can get your theta, is it not? Yes. Alright. I gave you theta equals to W2 plus W1 all over 2 times T. Is it not? Yes. Alright. So theta will be equals to what's W2? 2.88. Are you following? Yes. Then plus what's W1? 0. All over what? 2. What's my time? 6. Time is 6. Are you getting it? Yes. So 2.88 plus 0. 2.88. We still have 2.88 divided by 2 times what? 6. So theta will be equals to 2.88 times 6 divided by 2. We are divided by 2. 2.88 divided by 2. 1.44. Then times 6. 8 point what? 8.64 rad. Now that we've gotten our theta, then the D part, what are we asked to look for? We are asked to look for work done, our rotational kinetic energy, right? And to look for work done, that's W. Work done is written as torque theta. Work done is written as what? Work done is written as what? Now, we already have our moment of torque. What's our torque? What's our torque? What's our torque? 24. Now, work done will be equal to 24 Then times what's theta? What's theta? 8 point what? 64. So our W will be equal to multiply this. 207.36. What do you need? Joule. So the next one, we look for KER, right? Alright, to get KER is 1/2 IW square, is it not? So from there, our KER will be equals to 1/2 times, what's I? 50. Then times, what's W? This W, we are making use of this, is it not? 2 point what? 2.88 was square. So our KER will be equal to half is stating as what? Half is stating as what? That's good. 0.5 times what? 50 times 2.88 square. 8.2944. We have multiplied this. 207.36 what? Joule. Now if you observe, what do you have in your work done? And what do you have in your rotational kinetic energy? That means the working is what? Alright. So you can copy that. Any question, please? Which one? Yeah, this one. This one. Talk. This formula was gotten from, I gave you, from the beginning of my class, I gave you equation for linear motion and for what? For rotational or angular motion, is it not? And I told you, and for force is equal to what? MA. Is it not? Hello, force is equal to mass times what? Acceleration. So when you are converting this back to angular, I told you that your force is setting as what? Torque. Is it not? Your force is setting as what? Torque. Then y mass is setting as what? Y mass is setting as what? Moment of inertia. Is it not? Which is your what? I. And A is setting as what? Angular acceleration, which is your what? Alpha. So that is how they got that, which is this. Is that clear? Hello? That mean, Ali, you see the formula now, so you just know it. A disc as we're giving moment of inertia, right? I to be what? 0.250 kilogram meter square. And we're told that, and it's turning at what? 5 rev per second. That's W1, right? What do you do? Convert to what? How do you convert? 5 times 2 times 3.142. So what do we have there? 31.42 rad per seconds. And we are told that a trickle of sand, that little of it, falls onto the what? Disc. You know what the disc now, right? Then at a what? Distance of what? 30. That's our radius, right? 30 centimeter. How do you do? Convert to what? That is 30 over what? That is 0.3 meter. Now we are told that, okay, 30 centimeter radius ring of sand on it. How much sand must fall on the disc for it to slow to 3 rev? That from 5 to what? From 5 to 3, is it not? So this 3 rev be your what? Omega 2. That is 3 rev per what? That is 3 times 2 times 3.142. So what do we have? 18 point what? 852 rad per seconds. All right. They say how much of sand, that is the mass of it. Are you following? So you are looking for mass. I gave a formula that relates everything here. Okay. I gave you I, then W1 equals to I plus MR square, then W what? 2. Hello. Please from here, what are we looking for? W2. Sorry, mass. You can make mass the subject of the word formula, but before you do that, what do you do? Divide both sides by what? To make this one subject, you divide by W2 now, right? Or you just substitute the values direct. Okay, if you divide, since you have I, W1 equals to I plus MR square, I gave it to you, W2. If we divide by W2, pay attention, I want to derive it. So we have I1 plus MR square equals to IW1 all over W2. Is it not? All right. So from there, what do you do? To make it the subject of the formula, sorry, we can use W2 to open all the brackets. We have IW1 equals to, this times what do you have? IW2 plus W2 MR square. Is it not? All right. So from there, this one become IW1 minus IW2. Is it not? Then equals to what? W2 MR square. So from there, we are looking for M now, right? It can be IW1 minus IW2. Then all over what? W2 R square. That's M. Is it not? I gave you this now. I gave you this now. You don't need to factorize now. I gave you this now, right? Share the formula now. Okay, this one, you bring out the I. If you bring out I become M equals to, if you bring out I become W1 minus W2 over W2 R square. Is it not? This and this, they are still what? The same thing. Are you following? All right. So coming back, or should you use that direct? All right. We have M equals to I bracket W1 minus W2 over what? W2 R square. All right. So from there, our M will be equal to what's I? 0 point what? 25 what? 0. All right. Bracket, what's W1? What's W1? 31.42. What's W2? 18 point what? What's W2? Then times what's radius? 0 point what? 3 square. All right. So mass is equals to 0.250 bracket, subtract the bracket. 12 point what? 568 all over 18.852 times 0.3 square. 0.09. M will be equal to, multiply the numerator. 0.250 times 12.568. 3.14142. 225. Oh yeah, multiply the denominator. 1.69668. So mass will be equals to, divide this. 1.85. 1.85 kilogram. Is it 1.85? All right, so that's it. So any question there? You don't understand from where? All right, then brackets. What's our W1? 31.42, which is this. What's W2? 80.52, 80 point what? 852, which is this. All over. What's W2 again? 80.852 times. What's radius? What's radius? 0.3 square. So if you subtract the bracket, you arrive at this. Then if you square 0.3 square, it's going to give 0.09. And if you multiply these two, it's going to give you this. And if you multiply this, it's going to give you this. And if you divide, it will give you this. You only know where the rest. If you go as not be rest, you have go rest. Wait, no day they go for fire the house. I'm not going to do am.